Welcome back. In this final section of the program, we'll discuss the main parts of a typical programmable logic controller and explain how it is similar to, but different from, a relay logic controller. PLCs were designed to replace electromechanical control devices such as relays, counters and timers, which constitute the logic control devices of relay-controlled systems. So we find that the logic functions and programming languages for PLCs are derived from relay logic systems. If you are familiar with the basic concepts of relay ladder logic, then PLC ladder logic will not be difficult to grasp. To understand how a PLC managed system works, we need to understand how a PLC functions, how it receives yes/no input signals from the system, how it processes these signals to make decisions, and how it communicates these decisions to working devices. To begin with, this is how we could represent our block sorting machine under PLC control. This area represents the sensing devices providing yes/no messages as on/off voltage signals to the controller. And over here we have the output or working devices which are activated by the PLC. The input and output devices remain the same, but we would see a difference in the logic control circuits since the PLC contains numerous solid-state relays, counters and timers. These devices are fully programmable and can be arranged to create an almost endless combination of electrical control circuits. The PLC unit can be divided into three main parts: the input interface, the central processing unit, and the output interface. The input and output interface circuits, or I/Os as they are called, enable the PLC to communicate with the real world by exchanging signals with the CPU, whilst the CPU checks the inputs, solves the logic, and sets the state of the outputs. Let's discuss these components in a little more detail. The I/Os are either contained in modules or housings, or they are incorporated into the PLC unit itself. External devices are connected to the PLC via these cable termination blocks on the I/O interfaces, bringing signals in and sending signals out of the controller. The main function of the input interface is to protect the computer circuits within the PLC by electrically isolating and conditioning all incoming input voltage signals to the PLC. Outgoing signals from the controller are processed in a similar way through the output interface circuitry. For example, low voltage output signals are buffered via relays to isolate the PLC when it sends signals to high voltage output devices. The central processing unit is the heartbeat and intelligence of the system. On the basis of events that have been programmed into its memory, and the status of the various input and output devices that exchange signals with the PLC, decisions are made by the CPU that control the system. To communicate with our PLC, we use a programming device which may be a handheld type or a PC-based unit. The programmer enables us to program the PLC with the required logic to manage the system or to monitor the operation of the system during normal or troubleshooting conditions. As we continue to develop our understanding of PLCs and PLC-managed systems, you will realize that no matter how large or how small the process and the number of I/Os required, the system will always require sensing devices, input interfaces, logic circuits, output interfaces, external devices, and a means of programming the PLC with the logic necessary to control the process. This concludes Module 1 of the PLC training series. In the next module, we will be discussing different types of input, output, and logic devices, and how they combine to form the ladder logic diagram, which we will explain in detail.